Bismillahirrahmanirrahim. Assalamu alaikum students. I am Nadeem Khan from GIK College, Topi Sawabi, Pakistan. Today I am going to discuss a topic of class 9th chemistry chapter number 2, structure of atom. Today the name of my topic is defects in Rutherford's atomic model. We have discussed in our previous video what is the Rutherford atomic model, how nucleus was discovered using the Rutherford atomic model. So now we have discussed what are the defects or shortcomings, or you can say the drawbacks associated with the Rutherford atomic model. This can be one of your short question. So let me start with, I am going to discuss the first defect in Rutherford atomic model. According to classical electromagnetic theory, when one charged body like electron, this is the orbit, this is E is electron with negative charge, and this is the nucleus. When one charged body revolves around the another charged body, electron revolve around the nucleus. Both are charged particles. So the revolving electron will emit or release energy continuously in form of electromagnetic radiation. So as the electron revolves, it has some acceleration. It also changes its direction from point to point. That's why it releases energy. So when the electron releases energy, the orbit of revolving electron becomes smaller and smaller with the passage of time. Let's say, first of all, electron is revolving here. When it releases energy, its orbit will become smaller, and it will start revolving here. Then the orbit will get much more smaller and smaller. Ultimately this electron will fall into the nucleus. So this means the atom will collapse. When atom collapse, we know matter is composed of atoms. When atom collapse, this means matter collapse. If this was the situation, then there would have been nothing in the universe. The whole universe would be just in a space, vacant space. Nothing would be there. But actually this is not the reality. Atom is quite stable, and this stability is not explained by the Rutherford atomic model, how atom is stable. So this is not explained by the Rutherford atomic model. This is the first drawback. Stop. Now I am going to discuss the second drawback of Rutherford atomic model. The second drawback is that, let's say this is the nucleus and this is the electron. Electron revolves, emits energy continuously. When this energy is passed through prism, the light which passes through the prism, it will splits into various colors. This series of different colors are, sometimes they are the dark and white lines. If the light pass is invisible, for example ultraviolet or infrared light, if the light pass is visible, then we will have colors. So when this energy emitted by the atoms is passed through a prism or any spectrometer, we will get a spectrum. So when electron energy emits continuously, a continuous spectrum should be obtained. Let me discuss how a continuous spectrum looks like. Look at this. This arrangement is just like the rainbow. You have ever seen a rainbow. A rainbow has different colors. For example, violet, indigo, blue, green, yellow, orange, red. All colors which I say web gear. All the 7 colors are lying there. Violet, indigo, blue, green, yellow, orange, red. All colors are there, but these colors are mixed together. They are merged. They are overlapped. They don't have any, you can say, sharp boundaries through which they are separated. They are merged into each other. Such a spectrum is called continuous spectrum. Continuous spectrum. So when electron emits energy continuously, it should give us a continuous spectrum just like the rainbow. But the experiment shows that electrons do not give a continuous spectrum. It gives us a line spectrum. Look at this. This represents the line spectrum. You can see it's the violet, indigo, blue, green, yellow, orange, red. All the lines, all the colors, spectral lines or colors, these are separated from each other by sharp boundaries. This starts here, ends here. This starts here, ends here. This starts here and ends here. So all these are separated by sharp boundaries. They have sharp boundaries. This arrangement is called line spectrum. Line spectrum. So all atoms, not the molecules, atoms give line spectrum. So if the electron energy emits energy continuously, it should give continuous spectrum, but actually all atoms gives us line spectrum. This is not explained by the Rutherford's atomic model. So this is the second drawback of Rutherford atomic model. Dear students, in your book just two drawbacks of Rutherford atomic models are given, but I am going to discuss another one. Please listen it carefully. Also write it in your paper. So today now I am going to discuss the third drawback of Rutherford atomic model. Actually, the Rutherford said that electron revolve around the nucleus just like sun and other planets revolve around the sun. The other planets revolve around the sun. For example, this is the earth and this is sun. Earth is revolving around the sun. You know, earth carry no charge, sun carry no charge. But as far as atoms are concerned, the nucleus carry positive charge, electron carry negative charge. Here the force between them is electrostatic force of attraction. As far as earth and sun are concerned, if this analogy is totally wrong. Why? Because earth carry no charge, sun carry no charge, and they have gravitational forces of attraction. So how we can compare the neutral bodies with the charged bodies? So this comparison is totally wrong. Moreover, you can also write as a drawback that Rutherford just said electrons are present around the nucleus. What they are doing, how they are arranged, where they are present, this is not explained by the Rutherford atomic model. Actually, the chemical properties of the atoms depends upon how many electrons are there and how they are arranged. Arrangement and number of electrons around the nucleus, this determines the chemical properties. So in other words, we can say that Rutherford atomic model give no idea about the chemical properties of the atoms. Thank you very much, and I hope you will understand it, and if you don't understand, then you can call me through the WhatsApp, and I thank you all.